Uh, Hi guys, I'm gonna try to solve um, problem number 138. It has 11 likes and pretty much dislikes, but much smaller than likes. And then it has 51% of the acceptance rate, which means it's kind of difficult one. And there are some companies, there are lots of companies ask this question, within this period. It's amazing Amazon actually had a job position within this period. But this is important, this one and this one, I guess. So today I'm gonna try to solve this. So let's start the timer. Copy list with random pointer. A linked list of length n is given such that each node contains an additional random pointer, which could point to any node in the list or null. Okay. Construct a deep copy of the list. The deep copy should consist of exactly n brand new node where each node has its value set to the value of its corresponding original node. Okay. Both the next and random pointer of the new node should point to the new node in the copied list. It says is corresponding original node, which means the new node. You copy the list such that the pointer in the original list and copied list represent the same list state. None of the pointers in the new list should point to the node in the original list. For example, if you have two nodes x and y in the original list where x dot random points to y, then the corresponding two nodes, small x and small y, in the copied list, small x dot random, small y, return the head of the copied linked list. The linked list is represented in the input output as a list of n node. Each node is represented as a pair of val random index. Okay, val, an integer representing node dot val, random index, index of the node that the random pointer points to, or null if it does not point to any node. Your code will only be given the head of the original linked list. Okay. So let's say that there is a node, then 1, 2, 3, and then next is, since this is linked list, but somehow the random, somehow it could point to this one, or the random of this one could point to this one, and then the random of this one could point to I wonder whether random can random has null. random pointer, both next and the random pointer of the new node should point to the new node in the copied list. Okay, so it seems like random cannot have null, right? Oh, random can be null. Okay, so this one can be null. Okay, so in this case, so since this is head, we can copy this, and then since this is head, we can make this. Then one way to solve this is to have the two paths. So first path is create a O node, and then second path will create a random. But here the problem is that this guy knows that this is 3, but in the new node we don't know where the 3 is, right? And then val, if val is unique, then you can solve this rather simply, but I think this won't be unique. So one of the way is to store the pointer mapping into the map. So for example, if this is the original one, and then if this is the copied one, right? And then the pointer of this is this. The pointer of previous one and the new one can be stored. So that way we find that this is the pointer to the 3, and then here what's the new one for the 3? Oh, this one. I mean, some new one. And that will be retrieved. They could be retrieved and then set to 1. So there's the one way, which will work, but if there are many nodes, like 1000 nodes, we'll have O of n, space complexity. And let me think whether there's the other way. If we solve this problem is not that difficult. But if we want some other way, so what we can do is we can create this, and then next is this, so we can create this, and random is this, so we can create this. And here this one knows that the next one is something, and then it does not know whether that one is here. So you can create like this, and then this one, and then the next one is this one. This one does not, it needs next, and then it does not know whether what's the next. So this guy have next 3. So I will try to search whether next is already created, right? So if we have a map that is created by random node, random pointer, we can store the map into the map. In that case, we'll find this. So we can have this. Then this is null, so null is easy. And the next is 3. So in case of 3 needs to know whether its node is 2. But since we had a node for there's no way to know the node. Yeah, so it will not work. So let's try to have the map solution. So we have a map where original node and the copied node map, and then we'll have 4 node, pointer node. First is head, and then while node, next, right? So what I can do is, this is first pass, create all nodes N M, and then for the second pass, what you can do is that fill random. So here, so we need to return new head, and then this can be empty, so we can do if head return null pointer. So now we know that there must be a head, so we can do this like this, head. So initially, no, not like this. We'll have a new node where initially it is null pointer. So what you can do is that we create a new node, which is node file, right? New node. If new head is null pointer, then new head is new node, right? And then we will old, which is node, equals new node. We have to set the next, so we might want to have the prev node So here we do something like this, and then new node dot next prev node, and then after doing this, we can set prev node is new node, right? So in this case, when we go through one, this one is created, and then prev node is currently null. And when you go prev node is currently not. No, this is wrong. So we need probably we need we need head val, and then new head next is null pointer, and then here prev node is new head, then node is head then next. So if there is only and then prev node new node, prev new node, prev new node, and then prev new node is this one, something like this. So for example, if empty, then we'll just return this. If there is only one, then we'll create a new node. We might not need this one because this is null. And then new node is prev new node, and then this one won't be executed. So we're okay. So in case of 1, 2, one was created, and we'll go into here, and 2 is created, and it is new node, and we don't need this. And then prev new node, which is 1, is set to new node, and then we're gonna add this, and then and since we somehow I feel some dizzy, so head new head. So we have this, and then second pass. So I guess second pass is kind of easy. Now this new head. Now we are gonna start from the new head. So this is for the new node. So B, this is wrong, new node, and then node pointer, node old node is head, and then new node, new head, and then new node, and then new node, and old node, old node next, right? And then what you're gonna do is you're gonna see the old node random, one thing we can do is that m no pointer is no pointer. Do we need this? Because if it is null pointer added by in here, okay, we don't need this. So old node are random, we get this, and then this is a new node, a new pointer. So what we're gonna do is the new node, the random is this, right? So when this is null will be entered. When old node random is 3, this one's mapping is this one, so we'll add that, and then return new head. Yeah, so I think that's it. So we already went through the test case. Let's try this one, simple one. One is added. So here, prev node is 1. This one is created in here. This is 1, and then head next, which is the 2, right? Which is the 2. So 2 is created, and then 2 is added to the next. So we have now this. And then m node is new node, right? So we have the mapping for the new one. This one, and now we have this one. And then new node is prev new node, so which means that this one is now prev new node. And going to the node, now node is empty, no pointer. So we go here, and then go here. The old node random, which means that this one's random, which is 2, is get. This is a new one's new 2. So we set the right value. Cool, but very slow, because it has 2 paths. Let's run one more time. Faster, but it does not go to this way. Oh. So let me think about whether it can be solved with O of n, not 2 paths, just 1 path. So to do that within a 1 path, we have to create this one, in this case, this one and this one at the same time. And then when you go to this one, the second one, need to, we can do in 1 path. So what we can do is that what we can do is So let's remove this. Then create a node if it's not in M, right? So auto find M, find first what we can do is node dot next. Right? If found is not M and which means that we found, then found that next second, this is the auto next node, and then what you can do, you can declare node point no pointer, and then random node no pointer, right? And you create this. Before creating this node, we first need to find whether node is found node, and then in this case new node is this one, else you create new node equals new node node file, right? So we now have this, and then prev node. Can we start this from head like this? So let's try to find the head. Head is not in here, so we create a new node, and then here what we can do is that we try to create a next node. So if node next, and then do this. Then this one is next node, right? And then this one is next node. So so new node next is next node, and just also we need to set this one and then same to random. So let's fix random. Yeah, something like that. And new head, right? So this is pretty next node, not next node. Random node, random node, random node. So we may want to these are all same, so we may want to refactor this later. But yeah, we'll try to go through this case first when there's only one, and then let's say that this one actually points to itself. I mean random points to itself, and then next is null. So in the case here, this is a head, and then node is not in the map, so we're gonna find the node, right? So in this case, this one is created, and then new node will be added, and then node next is null, node random is null, and then it will go end, so it will work. And then let's think about the case where there is only 1 and 2. Only 1 and 2, right? And then so we're gonna think this one is like this, and this one is like this. In this case, this is 1, and then fan is so okay, and then this is 1 and 1 in here. 1 is created in here, and then node has next. So this one is not in the map, so 2 will be created also, right? And then it will be put into the map, okay? And then random is currently 2. This one is so, oh, I found it, and then the found one is put into the random. Random node. So here, random node is put into the random like this. And then it goes to the next 2. And then we found 2, right? So this is the new node. And then node next is null, and this is null. Node random is not null. So we need to try to find the random, which is 1. So we found 1. And then if this is found a new node, right? So we set the new node, new random node into random node. then this random node will be set into the new node's random. Alright, so 26 auto new head, we don't need this. $74. So we need this, but we need new head. So node pointer new head equals no PTL. Okay, and we need to set the new head actually. So here, if not new head, it should be new node, like this. Yeah. Okay. Okay. Submit again. Submit again. It does not go up to the. Interesting. Well, it's not getting any faster. But yeah, but I will try to check other solutions, but I think this is the one I'm thinking right now. It's not that difficult, but I'm thinking about, I was thinking the second pass, two pass approach, but I'm thinking one pass after that. So why shouldn't I come up with the first pass, one pass solution at the very first time? Why shouldn't I? I don't know. And then, I can, refactor this. But not right now. Okay. Yeah. Okay. This is it. See you next time.